Firstly, a very special good morning for all present here. Myself Neha. I am a student of BSc Chemistry on final year from Nikiram Sharma Government College, and today we are just going to cover the topic that is the organic chemistry, some basic principles and techniques. We are going to discuss about the types of organic reactions and mechanisms, methods of purification of organic compounds. Organic reactions can be classified into the following categories. There is the substitution reactions, addition reactions, elimination reactions, rearrangement reactions. Now, method of purification of organic compounds. Once an organic compound is extracted from a natural source or synthesized in the laboratory, it is essential to purify it. Various methods used for the purification of organic compounds are based on the nature of the compound and the impurity present in it. The common techniques used for the purifications are as follows: sublimation, crystallization, distillation, differential extraction, and chromatography. Finally, the purity of a compound is ascertained by determining its melting or boiling point. Most of the organic compounds have sharp melting point and boiling point. New methods for checking of purity of an organic compounds are based on different type of chromatographic and spectroscopic techniques. We have learned earlier that on heating, some solid substances changes from solid to vapor state without passing through the liquid state. The purification technique based on the above principle is known as sublimation and is used to separate sublimable compounds from non-sublimable impurities. Next is the crystallization. This is one of the most used technique for the purification of solid organic compounds. It is based on the difference in the solubilities of the compound and the impurities in a suitable solvent. The impure compound is dissolved in a solvent in which it is sparingly soluble at room temperature but appreciably soluble at higher temperature. The solution is concentrated to get a nearly saturated solution. On cooling the solution, pure compound crystallizes out and is removed by filtration. The filtrate, that is the mother liquor, contains impurities and small quantity of the compound. If the compound is highly soluble in one solvent and very little soluble in another solvent, crystallization can be satisfactorily carried out in a mixture of these solvents. Impurities which impart color to the solution are removed by crystallization becomes necessary for the purification of compounds containing impurities of comparable solubility. Next is distillation. This important method is used to separate volatile liquid from non-volatile impurities and the liquid having sufficient difference in their boiling points. Liquids having different boiling points vaporize at different temperature. The vapors are cooled and the liquids are so formed or collectively separately chloroform and aniline and are usually easily separated by the technique of distillation. The liquid mixture is taken in round bottom flask and heated carefully. On boiling, the vapors of liquid of lower boiling component are formed first. The vapors are condensed by using a condenser and the liquid is collected in a receiver. The vapors of higher boiling point form later and the liquid can be separated collectively. Fractional distillation. If the difference in boiling point of two liquids is not much, simple distillation cannot be used to separate them. The vapors of such liquids are formed within the same temperature range and are condensed simultaneously. The technique of the fractional distillation is used in such cases. In the technique, vapors of a liquid mixture are passed through a fractionating column before condensation. The fractionating column is fitted over the mouth of the round bottom flask. देखो vapors of the liquid with higher boiling point condenses before the vapors of the liquid with lower boiling point. The vapors rising up in the fractionating column become richer in more volatile component. By the time the vapor reach to the top of the fractionating column, and the fractionating column become richer in more volatile components. By the time the vapors reach to the top of the fractionating column, these are rich in more volatile components. Fractionating columns are available in various sizes and designs as shown in figure 12.7. A fractionating column provides many surfaces for heat exchange between the ascending vapors and the descending condensed vapor liquids. Some of the condensing liquid in the fractionating column obtains heat from the ascending vapors and revaporizes. The vapors thus become richer in a low boiling component. The vapors thus become richer in low boiling components. The vapors of low boiling component ascend to the top of the column. On reaching the top, the vapors become pure in low boiling component, pass through the condenser, and the pure liquid is collected in a receiver. After a series of successive distillations, the remaining liquid in the distillation flask get enriched in a high boiling component. Each successive condensation and vaporization unit, the fractionating column, is called a theoretical plate. Commercially, columns with hundreds of plates are available. One of the technological application of fractional distillation is to separate different fractions of crude oil in petroleum industry. Distillation under reduced pressure. This method is used to purify liquids having very high boiling point and those which decompose at below their boiling points. Such liquids are made to boil at a temperature lower than their normal boiling point by reducing the pressure on their surface. A liquid boils at a temperature at which its vapor phase is equal to the external pressure. The pressure is reduced with the help of water pump or vacuum pump. Glycerol can be separated from spent lye in soap industry by using this technique. Next is steam distillation. This technique is applied to separate substances which are steam volatile and are immiscible with water. In steam distillation, steam from a steam generator is passed through a heated flask containing the liquids to be distilled. The mixture of steam and the volatile organic compound is condensed and collected. The compound is later separated from water using a separating funnel. And steam distillation, the liquid boils when the sum of the vapor pressures due to the organic liquid P1 and that due to the water becomes equal to the atmospheric pressure P equal to P1 plus P2. Since P1 is the lower than P, the organic liquid vaporizes at lower temperature than its boiling point. Thus, if one of the substances in the mixture is water and other a water-soluble substance, then the mixture will boil close to but below 373 Kelvin. A mixture of water and the substances is obtained which can be separated by using a separating funnel. Aniline is separated by the technique from aniline water mixture. Next is the differential extraction. When an organic compound is present in aqueous medium, it is separated by shaking. Shaking it with organic solvent in which it is more soluble than in water. The organic solvent in the aqueous solution should be immiscible with each other so that they form two distinct layers which can be separated by separatory funnel. The organic solvent is later removed by distillation or by evaporation to get back the compound. Differential extraction is carried out in separatory funnel as shown in figure 12.10. If the organic compound is less soluble in organic solvent, a very large quantity of solvent would be required to extract even a very small quantity of the compound. The technique of continuous extraction is employed in such cases. In this technique, same solvent is repeatedly used for the extraction of the compound. Next is the chromatography. Chromatography is an important technique extensively used to separate mixture into their components, purify compounds and also to test the purity of the compound. The name chromatography is based on the Greek word chroma, the color, since the method was first used for the separation of the colored substances found in plants. In this technique, the mixture of substances applied onto a stationary phase, which may be solid or a liquid. A pure solvent or a mixture of solvent or a gas is allowed to move slowly over the stationary phase. The components of the mixture get gradually separated from one another. The moving phase is called the mobile phase. Based on the principle involved, chromatography can be classified into different categories. Two of these are the adsorption chromatography and the partition chromatography. Adsorption chromatography. Adsorption chromatography is based on the fact that the different compounds are adsorbed on the adsorbent to different degrees. Commonly used adsorbents are silica gel and alumina. When a mobile phase is allowed to move over a stationary phase, there is the adsorbent. The components of the mixture move by varying distances over the stationary phase. Following are two main types of chromatographic techniques based on the principle of differential adsorption. There is the column chromatography and the thin layer chromatography. Column chromatography involves the separation of mixture over a column of adsorbent packed in a glass tube. The column is fitted with a stopcock at its lower end. The mixture adsorbed on adsorbent is placed on the top of the adsorbent column placed in a glass tube. An appropriate eluent, which is liquid or a mixture of liquids, is allowed to flow down the column slowly. Depending upon the degree to which the compounds are adsorbed, complete separation takes place. The most readily adsorbed substances are retained near the top and others came down to various distances in the column. Next is the thin layer chromatography. Thin layer chromatography (TLC) is another type of adsorption chromatography which involves separation of substances of a mixture over a thin layer of an adsorbent coated on a glass plate. A thin layer about 0.2 mm thick of an adsorbent silica gel or alumina is spread over a glass plate of a suitable size. This plate is known as the thin layer chromatography plate or the chroma plate. The solution of the mixture to be separated is applied as a small spot about 2 cm above one end of the TLC plate. The glass plate is then placed in a closed jar containing an element. Here is the thin layer chromatogram being developed, and the eluent rises. The eluent rises upon the plate component of the mixture move along with the eluent to different distances depending on the degree of adsorption and separation take place. The relative adsorption of each component of the mixture is expressed in terms of the retardation factor or the RF values. RF values are distance moved by the substance from the baseline and the distance moved by the solvent from the baseline. The spot of colored compounds are visible on the TLC plate due to their original color. The spots of colorless compounds, which are invisible to the eye but fluorescence in ultraviolet light, can be detected by putting in the plate under the UV light. Another detection technique is to place the plate in a covered jar containing a few crystals of iodine. Spots of compounds which absorb iodine will show up in brown spots. Sometimes appropriate reagent may be also be sprayed on the plate. For example, amino acids may be detected by spraying the plate with an hydrogen solution. Partition chromatography. Partition chromatography is based on a continuous differential partitioning of the components of a mixture between stationary and the mobile phases. Paper chromatography is a type of partition chromatography. In paper chromatography, a special quality paper known as chromatography paper is used. Chromatography paper contains water trapped in it, which it is the stationary phase. A strip of chromatography paper spotted at the base within the solution of a mixture is suspended in a suitable solution or a mixture of the solvents. Thus, the solvent acts as the mobile phase. The solvent rises up the paper by capillary action and flows over the spot. The paper selectively retains different components according to their different partitioning in the two phases. The paper strips or developed is known as the chromatogram. The spots of the separated colored compounds are visible at different heights from the position of initial spot on the chromatogram. The spots of the separated colorless compounds may be observed either. There is 5 molecules of H2O. Copper sulfate is changes into copper sulfate dot 5H2O. Thank you.